So this is the stuff we need to know. Start off with triangles. What's it called if the triangle has three equal sides? Equilateral. What if it has two equal sides? Isosceles. Zero equal sides? Scalene. And then, of course, the angle is acute obtuse, right? On number one, the triangle, based on its angles, what kind of triangle is it? Right. Because it has one right angle. And based on its sides, what kind of triangle is it? Isosceles. Got two equal sides. So number one is kind of weird because it's both a right triangle and an isosceles triangle. What are those sides next to the right angle called in a right triangle? Legs. They're also called legs. You guys remember this in an isosceles triangle when they're equal? Those equal sides are called legs. Number three, got lots of questions. What it says, use the figure in exercise 1 to name the following. So looking at number 1, A, what are the legs on number 1? ZY and YX. And ZY and YX are line segments, right? So we're going to say segment ZY, segment YX. B, the vertex angle. So the vertex angle, that applies to isosceles triangles. You guys remember what it was? It was the angle between the two equal sides. Or the vertex between the two equal sides. So what angle is the vertex angle on number 1?
Y.
Angle Y. Between the two equal sides. And then C, the base, that would be on an isosceles triangle. So what's the base on number 1?
YX.
No.
Z.
The two equal sides are called the legs. The base is the other not equal side on an isosceles. So yeah, that would be ZX. D says, what's the hypotenuse on number 1? ZX again. On the right triangle, it's the hypotenuse. On the, if you think of it on isosceles, it's the base. But not all right triangles are isosceles. Not all isosceles are right triangles. Number 5. Which triangle appears to be congruent to the given triangle on number 5? Yeah, the triangle's kind of leaning over to the side, so it's kind of like C upside down. Okay, number 7. Name the congruent corresponding parts if triangle CAB is congruent to triangle TRS. How many congruent corresponding parts are there in two triangles? 6. There's 3 pairs of angles, 3 pairs of sides that are congruent. So what's a congruent pair of angles going to be? Angle C is congruent to angle T. And they all match. Anyway, angle A is congruent to angle R. So those are the congruent angles. How about the congruent sides? What would be a
CA is congruent to TR.
right, and sides are line segments. So segment CA is congruent to segment TR. Segment AB is congruent to segment RS. What's the missing side?
BC is congruent to CT.
BC is congruent to what?
I'm sorry, ST.
many congruent statements are required to show that triangles are congruent using definition of congruent triangles? So, the definition of congruent triangles is all these things we said on number 7, 3 pairs of congruent angles, 3 pairs of congruent sides. You need all 6 of those to say the triangles are congruent by definition of congruent triangles. All those have to be the same. So how many sets are there? 6. And we are skipping, do you guys notice we're skipping 10, 11? So I guess we're on to 13. I'm gonna draw this. X plus 15. Seven x plus 6. A, B, C, D. Okay, so it says we're supposed to, on number 13, find the measure of angle B if the measure of angle A is 59 degrees. So, any ideas what we could do? By the way, let me pause for a second. You guys know what kind of angle ACD is?
Acute.
Obtuse.
Acute.
Well, okay, if it's outside the triangle, what's it called if it's out here? Exterior angle. You guys remember what we know about exterior angles in a triangle?
Exterior angles.
No, it's not alternate interior. That's for parallel lines.
A plus B equals
Yes. On an exterior angle, it equals the sum of these two remote interior angles. So angle A plus angle B is going to equal this. But how do I figure out what x is?
4x plus 15 plus
No. We don't know what these two aren't related directly. Okay, they told us on 13 that angle A is 59 degrees.
So 59 plus that is going to equal 180.
No. These two are not really anything to each other. Okay, this angle right here is 4x plus 15. So what's that have to do with that?
you can plug in 59 for x.
No,
No, you do 4x plus 15
equals 59. They said this angle in the picture is 4x plus 15, and they said this angle equals 59. So they're equal to each other. And we can use that to solve for x.
This x equals no 11.
Okay, if x is 11, how can I use that?
Because you can plug in 11 for 7x plus 6.
Okay, figure out what that angle is. 7 times 11 is 77. Plus 6 is... Okay, now the question was, though, what's this angle over here? What's angle B? There's two ways to do
Well,
it.
you can do 180 minus 180 minus 83.
Okay, yeah, we could do 180 minus 83 to get this angle. And what do I know about these three angles? They equal 180. Or does anybody know the quicker way to do it?
Nope.
The exterior angle theorem. If this is an exterior angle, it should equal the sum of these two. So this plus this should equal 83.
Oh,
So 83 minus 59 is 24. No, it's right down here. Okay, but the first way you said would give you the same answer. Just takes a little bit longer to do it that way. Okay, for 15, let me pause for a second. This is the stuff we need to remember for this one. If this was like, that's okay. We'll just say this is 130. If this is 130, what's this angle right here going to be? 50. Because 180 minus 130 is 50. If this is 50, what's this angle going to be? Why?
Because it's an isosceles.
Right, in an isosceles triangle, the base angles are the same. Remember that trick? And if these are both 50, how do I find the vertex angle up here?
Those two minus
180 minus these two, yeah. 180 minus 100 is 8. Okay, anyway, that's kind of the tricks we need for 14 and 15. 14 is actually easier because it's just a bunch of numbers. However, if you get angle 1 wrong, then you're going to get angle 2 wrong, then you're going to get angle 3 wrong. So you've got to be kind of careful that you don't. Because if you get the first one in the chain wrong, it's going to kind of screw everything up. Angle 15, or number 15 is kind of the same thing as 14, except for there's no number. See if I can draw it. That's not very good. There we go. That'll do. Something like that. Okay, on 15 it says in the directions that angle 1 is x degrees. So it doesn't give us a way to figure out x. We're just supposed to write an expression. How would you figure out number 2? If this is x, how would you find angle 2?
180 minus.
Right, 180 minus x. So that's what we're going to write. Angle 2 equals 180 minus x. Alright, we're going to kind of go in order here. If angle 2 is 180 minus x, how do we find angle 3?
It's also 80, or it's like corresponding, or
It's not corresponding.
same base, or like.
They're
those-
base angles in an
base-
isosceles triangle.
Yeah.
So they have to be the same. So 2 and 3 are both 180 minus x. Okay. A little bit trickier. How do I find angle 4? We just said this is 180 minus x.
180 plus x, no. Angle 3 minus, angle 3 minus 180.
Well, you said it backwards. Just like we did over here. 180 minus this gives us this. So 180 minus this minus that gives us that. So 180 minus, you have to subtract all of it, so you need parentheses there. That. So 180 minus 180 minus x. So you kind of like distribute the minus. Minus x is actually a plus x. So what's going to happen to the 180s? So it's just x. Okay, Linux, why did you think it was x earlier?
Because it's the same.
Yeah, it's the.
Okay, because 2 and 3 are the same, these two are going to have to be the same, right? Because they're both 180 minus this gives you this. Anyway. Okay, now we're getting trickier. How could we find angle 5? Maybe I'll pause here again, ask you another question. If this is 40, how do I find like one of these angles?
Well, it's gonna equal.
40 minus 180 divided by 2.
180 minus 40, you guys are saying it backwards. That'll give you these two angles together. Since they have to be the same, you just divide it by 2, right? So if this is x up here, how would I find angle 5? minus x divided by 2. You can leave that. There is another way to write that. You could divide both of those by 2 and put 90 minus 1/2 x. But I don't think it's any simpler, so just leave it like that. Alright. If angle 5 is that, how do I find angle 6?
Well, it's the same thing.
Same thing, these are isosceles triangles, 5 and 6, so just kind of copy that answer down. Okay, one last angle.
What? Oh, there's something. No.
Alright, any ideas for 7?
Well,
Alternate interior angles only works on parallel lines, and we don't have any parallel lines here.
because 2 plus 3 plus 7 are going to equal 180.
Okay, we know these three have to add up to 180. Do I know anything about 6 and 7? No. But I do know 2, 3, and 7 have to add up to 180. So, let's say we knew these were both like 40 or something. How would I find this angle?
40 plus 40, 180.
180 minus these two, right?
Yeah.
So it's 180 minus 180. Go back to that. 180 minus x. 180 minus 180 minus x minus 180 minus x. That's one way you could write it. Which means we kind of did this one already, you guys remember this part? But there's another thing over here. So what's going to happen to the 180s?
Cancel.
Those two go away. X plus x is 2x minus 180. Okay, 14 is very similar to that except for you have actual numbers instead of just x's. No, we're gonna go, I went to number 21 with the other class. Okay, 16 through 21 says, if the triangles can be proved congruent, write a valid congruent statement. What are the ways we talked about that you can prove triangles are congruent? Huh?
Side,
Side,
side, side.
side, side.
Side,
Angle side, angle.
angle.
No.
They're just kidding.
Okay, that's one of the no-nos.
Side, side, angle. No, that's a no-no.
You found them all. Way to
You're
go.
welcome, guys. I was really hoping you wrote it down.
Yeah, the one that only works on right triangles, HL, which is actually like side side angle, but only for right triangles. Yeah, those are the 5. That's it. And these are the 2 that don't work, so don't try and use them. I didn't really read the full directions here. It says, if they are congruent, state a congruent statement, like this triangle is congruent to that triangle, and list what postulate or theorem that justifies it. These are the 5 postulates and theorems right here. If not, if we don't know that they're congruent, state an additional side or angle congruence that would enable the triangle to be proved congruent. It's kind of the same thing we did in the homework. If there's not enough info, we just say one more fact that would make it enough info. So 17, do we have enough information to say those 2 triangles are congruent?
Yeah.
By what?
Side, side, side.
Side, side, side. Remember, if they share AB, that counts as a third congruent side, right? So we're supposed to say a congruent statement like triangle, I'll say ADB is congruent to triangle what? If I go AD, B, what matches AD on the right triangle? Huh? No. So if you look at AD, see how it's like the two marks on the line? So that would match
BCA.
BC. Yeah, and then DB is like CA. It's all twisted around, but BCA would be the. Okay, and what theorem did we use again?
Side, side.
Side. 19. Do we have enough info there? What do we have?
Angle.
Angle. Is that one of them?
No.
No. So we need to list an extra fact that would make those two triangles congruent. Like if we throw in a side, then we'd have angle, side, angle, right? So what's a couple congruent sides that could be congruent?
TR.
I was gonna say RT.
Okay.
And WU.
Okay, that's fine. There's multiple options, but we only need one of them. Okay, that's all we have to put on that one. Let's see, we got time, I guess. I don't know if I want to talk about 20 or not. Maybe I'll let you.
We should definitely talk about one.
Well, maybe talk about it tomorrow. I'll let you guys look at it first. Okay, 21, however, the bow tie, or hourglass, I guess. It says that in the directions that AB and CD bisect each other. So what does that tell us? No. AB, segment AB and CD are bisecting each other. What does that mean?
That means E is the midpoint.
Yeah, and if he is the midpoint,
AE is the same as EB.
right?
And CE.
Yeah, they're cutting each other in half. Yes, that's what it means. And what else do I know just by looking at the picture?
Vertex angles.
Vertical angles.
Vertical angles.
Okay, so do we have enough info for this one?
Yes. Side
Side angle, side.
But
So if I say, let's say on the top triangle, if I go triangle ADE, so notice it's a bow tie, but it's like twisted because this one is like over here. If I say triangle ADE,
BCA. No, sorry, BCE.
yeah, I want to end on the two thing, right? So it would have to be like this, yeah, BCE.
Literally so small.
It's twisted around. And what was the theorem again? Side, technically that's a postulate. No, it's a biggie. All right, we'll pause there and wrap it up tomorrow. I might make you guys do 23 tomorrow. I don't think we have that much left.
I don't remember doing that.
23?